Yep, hello. Great. Hi, everyone. I apologize for the delay. I don't know what that was. We made some cool art, and then now we're back to blockchain land. So thank you, thank you very much for your interest in what we're working on. I'm going to have to kind of go through this relatively quickly because we spent so much time on the art portion of this process. So I think what's usually very useful is to look at, to get some shared context. And the shared context is around what is the problem we're solving. The problem we're solving is the fact that smart contracts can't know about events. So the world of events lives in market data, IoT data, all kinds of other data, ad exchange data. All this data represents contractual outcomes that you would want to write a contract about. But the reality is that the contracts that people are writing are about tokens because you can't write them about these events. This is called the Oracle problem or the smart contract connectivity problem. The fundamentals of the problem are that you have a blockchain network or smart contract network that secures transactions and packages of transactions called blocks with miners that you couldn't ask to retrieve API data, and you couldn't ask to be the trusted third party to execute events on your behalf. If you asked one miner, you would have a security hole in that one miner controlling the outcome of the contract. If you asked all the miners, you'd have thousands of API calls, and you'd introduce a critical security vulnerability. So fundamentally, there's no way that the security model of securing the contract state can allow people to interact with the outside world from the contract. What this does, in effect, is it limits us to tokenization. And tokenization is great, and I'm a big fan of it. But the reality is that the space can go much farther than tokenization. And it can go into decentralized finance, decentralized insurance, fraud-proof gaming, a whole bunch of other categories that really depend on various inputs and outputs, various critical events. And the way we're going to get there is we're going to have to solve this problem. We're basically going to have to create a middleware that bridges the gap between the events world and the contract world. And then people can build contracts around the various high-value events that they want to build them around. So this is the critical dynamic. Now, if we're able to solve this problem and we look at it through a historical kind of point of view, what would that mean? So generally speaking, historically, when you add features that greatly increase what people can build in our space, and you maintain the key security properties, you see step functions. You see a big shift in the value that people are able to deliver within our space. So the first shift was in like 13 or 14, where you went from built on Bitcoin multi-signature as the only contract, smart contract type, and you went on to protocol contracts, where you had to spend 3 to 6 months talking to protocol developers to add your contract. Then Ethereum took us from the protocol contracts, and it brought us into the world of scriptable contracts. And what it did was it added a bunch of features, it added a lot of ease of use, and it maintained the security of the space. So what Ethereum did is it allowed people to go from writing tokens or writing new contracts in months to days or weeks. And this ability to generate high-quality, secure code for new use cases like tokenization is what's led to all this activity. If you didn't have the ability to do that, it's very likely we wouldn't be in the position where we are today with tokens. What we're basically saying is that if we're able to solve this problem successfully, if we're able to make the events that contracts would be written about accessible, and if we're able to do that while maintaining the security of these smart contracts, and we're able to do it relatively easy to implement as a developer, there will be another step function in what people can create. And that step function will be what you see in DeFi. It'll be what you see in all these different categories that aren't just about tokens. Generally speaking, the solution to this problem of how do we get data into contracts is solved by oracles or blockchain middleware. That's essentially what we work on. So what our goal is to get data securely into smart contracts, is to get smart contracts to be able to use other systems by generating events. Some critical events are things like payment events. and a bunch of various other events. So there's the need for inputs to trigger the contract, and there's the need for the contract to trigger outside events, either in an enterprise backend, in a traditional payment system, or any other collection of systems, right? And this interoperability between inputs and outputs is the critical dimension, we feel, of the next stage of how the space will develop. Also, oracles have a cross-chain component, even though it's still relatively early for that, based on where you actually have inputs and outputs going to and from chains. Generally speaking, the thing that we've noticed from building contracts, smart contracts for about 6 years, and from building externally connected smart contracts for a large number of those years, is that what you're really doing when you're taking a smart contract and you're expanding it to interact with inputs and outputs is you're expanding what you define as a smart contract. Right now, in the world of tokenization, you define a smart contract as a piece of code that manipulates a ledger, and that ledger lives on chain, and the code lives on chain, and it's its own encapsulated system, where the data the contract interacts with and the logic that it uses to interact with that data is all in one encapsulated kind of system, right? That's like Ethereum or whatever chain you want. And that's why the security model works, right? Because the surface area is just that system. What we're saying is we want to expand what we can do, which means we expand the amount of systems we interact with, which means we expand the surface area. We expand our definition of a contract. And in that expansion, two things happen, and they're kind of opposed. The first thing that happens is we get a lot of inputs and outputs that are very valuable. They can be combined into very high-value contracts and DeFi and decentralized insurance and all these different categories. The second thing that happens is we now have surface area that we need to secure. And if we don't secure it, the key property of a smart contract, which is its security and reliability, may very well disappear. And then there's very little uniqueness to this technology if it's not secure. Because the entire efficiency gain of a smart contract is that it's so secure and reliable that we can have it programmatically trigger things and own things and hold value and do things in a very efficient way, more efficient than less secure, less reliable systems. So generally speaking, the security of this new form of contract, the contract that's both on-chain and in Oracle, is a key property. Now, our approach to generating this security is something I'm going to walk through briefly here. I'm going to walk through in the presentation, and then I'm going to show some new parts of the system that expand on how we're doing that. So the key core of the approach is decentralization. That means you have multiple Oracle mechanisms, multiple independent node operators performing the computation you need performed. And this computation is right now specific to data delivery and the generation of outputs, inputs, those things. When you have an Oracle that's responsible for giving you very critical inputs without which your contract won't function, or which you need to generate something like payment outputs, you probably want as strong a commitment as you can get from that other system that it will correctly trigger your contract and it'll correctly trigger events on behalf of your contract. So this is where we have something called service agreements, which have a very high-cost, binding, very clear relationship-forming kind of nature between the user contract and the Oracle. All of this essentially generates data that can lead to provable reliability for both individual nodes and networks of nodes. We also practice defense in depth, which I don't know if I'll have time to get into the trusted execution part of what we do, but defense in depth means we layer on different security approaches. And then we also have a large open source community of node operators, secure integration code developers, and various people that do security research on an academic level, people that do practical things in security like auditing. So just to be clear, just so we have the shared context here, because that context is very important, the real problem we're trying to avoid is a centralization risk in regards to this new part of the contract. And that centralization risk basically looks like this. You have decentralized computation that arrives at the state change that you hold reliable and secure, but you don't have something as reliable as that to trigger it. You don't have that on the middleware level, and you don't have that on the data level unless you have a system that decentralizes the Oracle mechanism and provides various other security guarantees. Generally speaking, that's the core of what we do. is we apply decentralized computation to the Oracle mechanism, and we layer on as many various guarantees from the Oracle mechanism to the contract as we can, which then generates data, which then allows people to make informed decisions about the degree and type of decentralized computation they want to purchase to solve this risk. Generally speaking, once you have decentralization, that's great, but there's actually a lot of other dimensions to it. There's dimensions like Sybil resistance, where you might want to know who the node operators are. You might want the node operators to make very clear commitments that they're going to deliver very specific data at a very specific level of quality over a very set timeline, and that they have very good economic incentives to deliver that data correctly. All of that is defined in something we call a service agreement. That also ends up generating a lot of data about the relationship between an Oracle and a user contract. Once you decentralize the middleware layer, you can then go on and you can decentralize the data provider level. But the first key part is decentralizing the middleware level, because really that's the surface area that's weakest in all these setups. It's probably not the data providers that have secured their infrastructure for years. It's probably not the contract network. It's probably the middleware level, where you have to get a high level of security, and then hopefully that security will help you form an even more secure relationship with these other non-blockchain data systems and payment systems. So let's look at an example. A simple example is a DeFi example where you have a derivative. The derivative is based on an outcome. The outcome could be the price reaches a threshold of, I don't know, $10,000, right? If the price of something reaches a threshold of $10,000, then you want the contract to be triggered. You want something to be liquidated. You want to mark to market. You want some kind of event, a state change in the contract. Generally speaking, we think the right model is that if you have $1 worth of value in that contract, maybe you only need one Oracle. Maybe you don't need to purchase massive levels of decentralization to secure your $1 contract. However, if your contract then goes to $1 million, then you might want to reassess the risk you have in relation to the Oracle mechanism, and you might want to consider increasing the security of that mechanism. And then as you go from $1 million to $100 million in that market, then you would also want to think about going beyond 3 to 5 to 7, 15, 21 Oracles more, right? Because you're relying on the decentralized computation of the contract state change, which is usually over-decentralized to a massive degree, which is fine, which is great. That system can work. But the Oracle mechanism, at least in our model, is something you can decentralize relative to the value that it's securing, and you can require greater degrees of security from it relative to the value it's securing, so that if the value of the DeFi contract is low, the cost of securing it from the Oracle mechanism is low. If the value is high, the cost of securing it is higher, but you're getting the degree of security that you want to pay for, which could mean a very high degree. Generally speaking, you then also need to pay, and that's where payment systems come in. So oracles are very, very, very useful for both inputs and outputs. Outputs can be things like, I want to pay another chain, I want to pay using a stable coin somewhere else, I want to use a bank payment, I want to do a retail payment with a PayPal adapter. Basically, the ability for a developer to make all the choices he wants, the way he wants about inputs and outputs, is what oracles really provide. Now, after we look at the security of how oracles provide the guarantees they do, one of the next layers in this series of questions is, how do we make these oracles consumable? So once we've made the oracles secure, how do we make it so that developers can actually implement them into their decentralized applications in a way that actually creates efficiency, actually allows them to build those applications the way web application developers build, right? Web application developers build like a day, a couple of days, maybe a week, write some core code, put together some APIs, right? We want to get the decentralized application developers to the same level of ease of use, where they can make some kind of externally connected application in a day, and they don't need to worry about the security of those relationships. Because if they do, then it won't take a day. It'll take a year or more. It'll take weeks. It'll take a while. So generally speaking, that's another dimension to consider. That's the dimension that we're going to dive into a little bit deeper. So what I just showed you was the direct model. The direct model was when you form a binding service agreement just for your contract, you say, I want an esports outcome. And I just want it for me, and I don't care about anybody else. I want to guarantee that the esports outcome will arrive to me in my contract, and I want XYZ guarantees. There's other models where there's on-chain reference data model, and the on-chain reference data model basically allows for on-chain data to exist and for contracts to simply read that data. This is actually an easier model for consumption. It doesn't provide the relevant level of guarantees between the high level of guarantees, but if somebody is sure that all they ever need is that piece of data, and they have assurances that that piece of data is going to continually get written on chain the way it needs to, then it's possible they gain the benefits of ease of use without having the costs or the complexity of this direct model. The other part of this is as people use oracles, that generates a lot of data, and that data is very authoritative because it's very hard to game. Blockchains have built-in anti-spam mechanisms, it's immutable, and the nature of these service agreements and these other clearly defining relationship parts of our system make it so that you get some predictable value from the fact that somebody has performed as an oracle and somebody has put up stake as an oracle and those types of things. Other than that, I'm going to quickly cover how expansion of computational capabilities in oracles and oracle networks can result in truly fascinating and super valuable dynamics around privacy. And then, I don't know if I'm going to have time for this, but trusted execution environments, how those can be layered on as an additional layer of security. Generally speaking, in our system, we allow people to choose both the individual node operator and the tasks that node operator will be performing so that they can compose an oracle network at a very granular level. So if you're using the direct model, the way this looks is you go to the Chainlink marketplace, you type in whatever resource you need, and you basically start selecting the node operators. You look at what data providers they support, you look at their history, you look at what infrastructure they run on. You can learn things like whether they're running their own Ethereum node or whether they're broadcasting through Infura. And what you basically do is you make a thoughtful decision about these are the 2, 3, 4, 5, 7, 21 node operators I want. And in a very simple architectural sense, that's what this looks like. You go, you decide who are my node operators. I'm going to have a direct service agreement relationship with them for very specific work. Here's the specific work. Here's an example of a single job. This is a job that gets BTC USD price data from one data provider. That's all it does. This job could have many other tasks. It could have computational tasks on top of that data. It could have aggregation tasks from other data providers. But essentially, what you're doing is you're defining the node operator, you're defining the work they're going to be doing for you, and you're defining, in the process of defining that work, you're defining who the data providers that are providing that data would be. If you don't see an adapter, if you don't see a job, a function that you need, we're open source. So the benefits of open source are really twofold. One part of it is we could have a bounty program, and we're looking at a bounty program where people build the adapters that community members and users want. The other part of it is if you build an adapter and you put it in this community, people are going to look at it. So people, especially if other people want to use it. So there's also a capacity to have a cumulative effect from the fact that people do need all of these inputs and outputs, and they do need and want them reviewed for security. After that point, after let's say you added a new payment method that wasn't there before, great. Now you have a new payment method. We actually do have a PayPal adapter. We have other adapters for other payment methods. But in the direct model, you've chosen the node operator you want. You've chosen the job, the work they're going to do, and you've chosen the payment outputs you're going to have. And you have a fully connected contract with all the necessary inputs, necessary outputs, and all the necessary degrees of security that you would want to know about that. Now, that's the direct model. And the direct model is a bit more involved. It provides you service agreements, and it's usually useful for situations where there isn't a common need for the data. Like the data's from a specific IoT data source you only care about, or it's from or you want the data private, or you want the service agreement to do some very specific computations around the data, which I'll get into some of that can be used for privacy. The next version of all this is the reference data side, basically. Generally speaking, the way reference data works is there's an authoritative piece of data that a lot of other people drive their systems off of. And what we're showing here is an authoritative piece of data on chain for the ETH/USD price. It's composed of 15 node operators. Those node operators are Sybil resistant, as in they're identified. They've been security reviewed. We've learned about their infrastructure. We've learned a lot of critical pieces of information about their security. And right now, at the moment, this is the most decentralized, according to us, the most secure ETH/USD price on chain, right? So and this price is available for free to all DeFi dApp developers right now. We've had it running for 3 months without any problems, and we have a number of people using it. And what we're really looking at is now that we have this working for 3 months, how do we make reference data work for the DeFi space, right? We have a good security model. We have great node operators. We have a framework to show their security. We have a large amount of data providers plugged into the node operators. So you can have a diversity of data providers that aren't exchanges. They're like data aggregators that smooth out problems with data. Now, what we're thrilled to announce here at the conference is that we're going to be heavily expanding the reference data side of what we're doing. The first 3 months of what we were building was really about testing out and making sure the security of these reference data contracts and this approach works. And right now, from our point of view, it completely works. Like I said, we have the largest, most decentralized source, most identified, most security reviewed source of ETH/USD price on chain. What we're going to be doing going forward is we're going to be releasing an additional 7 Oracle networks just like this one. So those 7 additional Oracle networks that are going to be released are going to greatly expand what people can build in this space. What this means is that decentralized finance developers won't even need to form a service agreement. They'll just have a contract on chain that puts critical price data on chain that they could read from without needing to pay anybody, without making any service agreements. I mean, this is something that we're doing to jumpstart the speed at which people can build DeFi products. And we're committing right now to expand an additional 7 reference data Oracle networks like this one, and then probably many more beyond that. So the goal for us as a group of people, as a company, is to really take decentralized finance to the next level. And taking decentralized finance to the next level really, in our opinion, requires both the direct model and the good reference data model. And the reference data model isn't going to exist for every piece of data under the sun. It's going to exist for the pieces of data that are widely used, and it's going to make that data very easily accessible. And that's something we're thrilled to put a lot of resources behind and make that our contribution to the DeFi kind of movement and revolution, all those things. All we do is make oracles, and the reality is that the best way for people to consume certain classes of data is in this reference data contract model. And that's true for certain categories of data. Other categories where maybe you want to define some computation around the data, that's not exactly true, right? Because that wouldn't apply to everybody. But we're thrilled to be making a commitment to greatly expand the amount of reference data on chain with at least these 7 new Oracle networks. We're going to have details out about this in a blog post before or by DevCon. And those details are going to define the networks that we're putting out and a number of other key pieces of information. What we're going to be definitely doing are key networks like BTC USD and others. And those details should be out before, well before DevCon. We're also very heavily collaborating with key DeFi projects Compound, Synthetics, a number of other folks, and we invite all the other DeFi projects out there that want an impartial, long-term shared reference data resource to come talk to us about what are the price pairs, what are the shared reference data kind of pieces of data that they really need. Because what we're going to do is we're going to prioritize what the whole space needs, and at the end of the day, it'll create a situation where a developer can just show up and they'll just have a contract where they can get a price. And that'll be the fastest way for people to build DeFi, and I think that'll accelerate things pretty rapidly. Generally speaking, after you make a set of good reference data contracts, I think one of the key things that'll happen is you'll have a network effect where there'll be a number of users. You'll know those users are distinct, and that will create a web of trust model. So the fact that you have 5 DeFi projects, a gaming project, and some insurance project, all using the same Oracle contract, creates a web of trust. And this web of trust basically generates a very high signal of security, along with other dynamics like staking and all the data-driven dynamics around proving that the Oracle is secure. Generally speaking, we think over the long term, a set of reference data contracts that's open source, managed by an impartial kind of community that's only focused on making high-quality oracles their focus and their goal, that don't have any competitive dynamics, don't have any other reason for people not to use these contracts, is the right long-term approach. And as more people use that, it'll show in the on-chain data, which will make the reference data contracts even more reliable or even more trustworthy, because so many other people have vetted it and they're signaling that by their usage. So they're not just signaling that by saying things. Usage is signaling. That's fundamentally where the key signing piece of the web of trust comes in. Generally speaking, I think if we're able to do this, the thing that we're really going for is that somebody can come into our space and in one day they can build a contract for something like crop insurance. They can sit down, they can take some core code, they can connect up with all the different, in this case it's weather data. They can get really reliable weather data that's redundantly reported from multiple sources, multiple oracles. That level of reliability, coupled with the level of reliability of the contract, allows them to build an insurance product that might not need people. The degree of reliability that they get from the end-to-end life cycle of a decentralized collection of data sources, a decentralized Oracle mechanism to trigger the contract, a decentralized state change mechanism, and then hopefully some kind of highly reliable payments mechanism, means that they can create the efficiency that we all want from these contracts, right? So we want them to make these contracts very quickly, so they can iterate out on them and build great contracts just like web developers build great web apps. We want people to do that in a secure manner, so that just like developers don't worry about the core security of Ethereum, they just have to follow some development practices, and they get security from that. That's a similar model. And we want them to have a huge amount of choice in terms of the inputs and outputs. Now, I don't have as much time to go into another piece of why oracles are very important, which is called mixicles. It's actually a really exciting kind of paper that we released recently, and I think it was a very detailed piece of work, and so it might not have been clear exactly what its exact value is. Generally speaking, privacy is extremely important, because without privacy, many types of contracts can't exist, because the contract would create adversarial dynamics in terms of trading, it would create adversarial dynamics for legal reasons. This is why there's an entire category of our space called private blockchains, right? It's not a coincidence. They're called private blockchains. And they're taking a huge part of the usage that could be on public chains. And they're doing that on the basis of privacy, right? Because there's huge groups of contracts, even like the insurance contract I showed, the DeFi contract I showed, where without privacy, that contract simply wouldn't exist. Because that's how realistically contracts work. And many contracts, not all, but many. For example, the insurance company wouldn't want people to know they're paying out a policy. A recipient of a payout might not want the whole world to know that they just got $10 million from an insurance policy, right? These are the types of pieces of information where, if they're not private, people might not want to do the contract. So what Mixicals do is they apply oracles as a mechanism to generate privacy. So what they do is they put a portion of the computation into the oracle itself, and that computation being in the oracle means that you can have different contracts handle state change or payment or any other piece that are uncorrelated. And this creates privacy in public chain environments. So you get the benefit of public chain environments with a huge amount of developer tools, a large network effect of users, a lot of value for people that want to publish contracts into those infrastructures. And now you can have privacy if you can have an oracle mechanism that you can rely on to do a portion of the computation. And the oracle mechanism doing a portion of the computation creates this privacy, because the oracle mechanism can be made private, because you have complete control over who the node operators are, what infrastructure they run, and even whether they use something called SGX and trusted execution environments. Those environments essentially even create more privacy, such that whatever the oracle operators are doing, they don't even know what that is. So you could have a collection of node operators that are executing private computations for you that you gave them as encrypted code that they don't know what that is. Unfortunately, I won't have time to go into how trusted execution environments layer on as an additional level of security. But generally speaking, we're very excited about how far DeFi has come. We're very excited about doing our best to really contribute and do our part to help take it to the next level. We've done a good job so far at making the direct model work and allowing people to intelligently select oracles, intelligently define their work, and intelligently form commitments between their contracts and the oracles. What we think part of the next step is creating a huge collection of reference data contracts and reference data oracle networks that will serve the needs of a lot of the developers coming specifically into DeFi. And we're very excited about that. We'll have more details on it soon. And if you're building a DeFi application and you need some kind of data on chain, please come talk to us, email us. We're going to have a new form up soon for people to inform us. We might have a voting process. We're gonna think about how after these initial 7, how do we want more reference data contracts, more reference data sets to make their way on chain, so that people can build great DeFi products both quickly and securely. Okay, thank you very much.